All right, here we go. Another video on some trig functions now. That's finding the 6 trig functions. Chapter 4.2, 6 trig functions. So here we go. We can start off with the basics. We have the sine of theta is equal to opposite over the hypotenuse. And we'll look at a triangle in a second, but we have the opposite side of the angle over the hypotenuse, which is also the y category, or the y component, over h, the hypotenuse. We have cosine of theta is adjacent over hypotenuse, the adjacent side, which is the x component over the hypotenuse. Tangent of theta is equal to the opposite over adjacent. Now, you might be familiar with these as SOHCAHTOA, right? Seen that before. So, here we go with tangent of theta was the y over x category there. All right. Now, those are the main 3 that we have. Now, in order to introduce the next 3, we're going to look at them as what we call reciprocal identities. So they are these functions in the reciprocal realm. So let's see what we have. We have cosecant, which is shortened up by CSC. So the cosecant of theta is the hypotenuse over the opposite. So again, it's the reciprocal of the sine function. All right. Secant is SEC of theta, so this is how it's shortened up here. And it is the hypotenuse over the adjacent. Okay? It ties in closely with the sine function, right? Or the cosine function right here. All right? So now, get that. Bring it back over this way. And then we have cotangent. Cotangent is adjacent over the opposite, or the opposite. And so that is the x over y category. Now, we also might see these reciprocal identities as h over y for cosecant, or we might just see it as 1 over y. Now, you might want to stop the video and ask yourself, well, when would it be 1 over y? Think about the unit circle. I don't know. Okay, so also h over x for secant is the hypotenuse over the adjacent side, which is also the 1 over x. Cotangent is adjacent over opposite, which I said was x over y. All right, so let's look at an example of how we can find these functions. All right, so here we have our first example. And we are given example number 1. Find the 6 trig functions of pi over 6. Now you might recall that 30 degrees is pi over 6. So here we have a little triangle. 30 degrees, 60. The values are 1, 2, and root 3. And there's a proof for those. We did that in class. So sine of pi over 6, well, it wants the opposite over the hypotenuse. So here's 30. The opposite side is 1. The hypotenuse is 2, so 1/2. Cosine of pi over 6. Well, that's the adjacent side over the hypotenuse. Adjacent side is root 3 over the hypotenuse, which is 2, so root 3 over 2. Tangent of pi over 6 is opposite over adjacent, and we get 1 over root 3, so opposite over adjacent, so 1 over root 3. And after we rationalize the denominator, we end up with root 3 over 3. All right? Finally, we have cosecant. Cosecant is the hypotenuse over the opposite. So that was the reciprocal of 2 over 1. So we get, or 1 over 2. So we get 2 over 1. Secant of pi over 6 is hypotenuse over adjacent. And that ends up being 2 over root 3. But we have to rationalize that denominator. So your result will be 2 root 3 over 3. Hopefully you can see that. 2 root 3 over 3. And cotangent is adjacent over opposite, or root 3 over 1. Again, just the reciprocal of this function. Now, I didn't change it from the root 3 over 3 because it was already in a good form here with 1 over root 3 as their equal values. All right. Example number 2 is this: find the 6 trig functions if there's a point given, and that point is negative 1/2 and root 3 over 2. So remember, this is the x and this is the y component. And if you recall from our notes before, r times the cosine of theta is the x value. R times the sine of theta is the y. Now we're not given a theta value here, so we're just basing everything off these x and y points. Sine of theta is root 3 over 2, just the y component. Cosine is negative 1/2, just the x component. Tangent is root 3 over 2 divided by negative 1/2, or y over x, right? And if we simplify, we can get rid of these 2's, and we end up with negative root 3 over 2. We go over here to cosecant, and this is 2 over root 3. But remember, we should rationalize the denominator, so we multiply top and bottom by root 3, and that gives us 2 root 3 over 3 as a result. Secant is negative 2 over 1. Well, that's because it's the reciprocal of negative 1/2. And finally, cotangent is negative 1/2 over root 3 over 2. And again, if we simplify those 2's out, we get negative 1 over root 3. If I multiply by the square root of 3, top and bottom, we'll end up with a result of negative root 3 over 3 as our cotangent for the given points. All right, hope you've enjoyed. Go back, rewind this, play it again if you need more help. Thanks, have a great day.